Okay, we're good. So I'm sort of ADD. I have trouble talking about one topic unless I'm really excited about it. So we're going to do 4 tonight. I haven't really decided on order. I guess we might as well go in alpha. No, let's do Rubinius first because I think it's the most interesting. Who knows about Rubinius? Hands anywhere? Like, it's completely new to some people, or okay. How much do we know? How many know that it's a virtual machine? Hands. How many know what features it has different from Matz's Ruby? How many have used it? Built it? Downloaded it? Looked at the website? Looked at the website? Okay. Again, with the obvious, Rubinius is a virtual machine for Ruby. But it's different from the other implementations in that the goal was to have as much Ruby as possible implementing Ruby, which is a little weird. But other languages do it too. Smalltalk has several virtual machines, largely written in Smalltalk or completely written in Smalltalk in certain cases. But Evan Phoenix, who founded the project, his philosophy was, I'm a Rubyist. I like writing Ruby. Other Rubyists like writing Ruby. If we're going to write Ruby, it should be in Ruby. So what that's come down to is a core kernel that is in C, and Evan's actually writing a new version that's in C++. I believe because he believes it can be tested better. This is the 3rd or 4th iteration. You know, as you're building things, you have new requirements. But by and far, the core library is mostly written in Ruby, which is really cool because it allows people to jump in and implement really basic methods simply in ways they understand. So people who are excited about Ruby can now write Ruby itself. And let's see how it's different from the other implementations. So you've got JRuby, which is targeted JVM. You've got Iron Ruby, which is on the CLR. Cardinal, which is on Parrot, right, for Perl. Rubinius is sort of in the middle as far as the completeness spectrum goes. It runs some things, it doesn't run others, but it's able to bootstrap itself, which is a huge milestone. It's able to run things like IRB, which seems simple, but is actually ridiculously complex because you have to get all of the evaluation stuff from a string properly on the fly, which can be interesting for something like Rubinius, which compiles to bytecode. So that's another way it's different from some of the other implementations. It does compile to bytecode, and then you are running from RBC files, not RB files itself. Really, what I want to jump into is all the cool things that I think make Rubinius really cool. Some people don't agree with me on this, but I really think that Rubinius is a new version of the Ruby language. I think it's equivalent to a Ruby 2 fork, and while it's 1.8 compatible, it does a lot of things that Matz's Ruby doesn't, and I think moves forward with the spirit of what Ruby is. So what I want to do is show you some of the things it can do and show you some of the code, and then maybe talk about contributing to it a little bit. So first of all, how many people know the binding of caller hack? So, wow, okay. So binding of caller is a method which sort of exploits certain features in Ruby in order to get the binding of the method that called the method you're in. You're asking for the method sender so that you can call back into it for certain purposes. I can't actually think of the use for it right now, but it's used in various break pointers and debugging tools. I'm sorry? Yeah, I think it was used in breakpoint RB in the first place. Anyway, so it's sort of complicated and sort of exploits a bug in Ruby. In Rubinius, everything breaks down to a method context object. So if we drop into Rubinius, here's another neat thing. If you run Rubinius itself, it just sort of expects you on a shell, and drops you into IRB. So here's the IRB prompt. 3 plus 4, 7. Is that big enough? Can you see? Should I bump it up further? Okay. So even at this prompt, we can say method context dot current and get the context of where we are. We can see the binding is an IRB binding. It's in the IRB sort of meta file thing, line 4, and it's a block context, and that's pretty cool. But what's cooler is that you can say current.sender, and that is the method that called this method right there. There is no additional work needed because Rubinius uses something called a spaghetti stack. So what happens in Matz's Ruby is for every method call that's invoked, it goes into C, it creates it calls a C function which looks up the Ruby functions and then executes them. In Rubinius, all of this happens in Ruby. So it essentially has a big while loop that says grab the next bytecode and execute it. And all the Ruby does is shove the next bytecode into the right place. And what that means is when we create a new method, it creates a new method context. It literally, if you look at the code, at least it did this at one point, you literally create a new method context, then you set the sender on the method context to this method context, and then when you're bailing out later, you set the current method context to the sender method context. So you're dealing with it all in Ruby without dealing with any of the C stack stuff. Which, let's see. So that's method context. You can actually access these things as they're happening. And if you look at methods here, there's actually lots of different things you can introspect on. So what's happening to the Rubinius stack pointer? What line we're on? What file we're dealing with? So just like you can introspect into the objects and figure out what methods there are and what's going on, with Rubinius you can do that at the environment level. This also lets you do things like, well, let's do the compiled method next. So when you create a method, def foo abc plus b plus c. So you'll notice that the returned value for this method definition is a compiled method object. So when you're doing a definition, what it's literally doing is creating an object, putting it in the method table with these attributes. So you'll notice on the return value we've got the name foo and the file attached to it. So what this means is that, let me grab a different method. So string.method split. I think I can do that. Okay, so this one's special because it's defined in the kernel. But let's just do it with foo. So we all know the method. You can pass a symbol to method, and it returns the actual object, which is essentially a proc, and you can call. In this case, we can also ask for the compiled method. And now we're back to the place where we can introspect further on where the method was created, what line we're executing. So interesting sort of hacky use case for this. I had a buddy, actually this was Coda Hale, who was mentioned last talk. Couldn't figure out why this method was always returning nil, and realized that a method in the library had been overridden by some other library. So where is this defined? What's going on? This sucks. What I'd really like to do is say, here's the method. Where does it exist? In Rubinius, this is literally, in fact, let's try to do it with split. I'm not sure if this will work. Current method. Okay, so because this one is a special method, we can't do it. But on foo, we are able to say what file is this, and I think you can say what line as well. No, maybe not. Maybe it's the line number. I think it's line from IP, line from instruction pointer. Unless it requires a number. Anyway, you can do this out of the box in Rubinius, because everything is a Ruby object, essentially. Let's go show the call stack in a second. Who knows what an S expression is? Any Lisp programmers in the house? Or people who saw my Heckle talk last year at some point? Anyway, so if you take syntax in code, at least in many languages, you can break this down into something called an S expression, which defines argument. You know what? Let me just show it to you. Let's say we've got def foo a b c, a plus b plus c. Let's say we've got this defined somewhere. Internally, what this looks like in Rubinius is this. We've got a new line node for an eval. We've got a definition of a method called foo, which creates a new scope, which has a block with arguments a, b, and c. I think this is passing bindings and blocks. There's a new line and a call using a local variable and the plus operator to an array. So it does some mangling in here to get a normalized S expression. But from Rubinius, out of the box, you can grab the syntax tree. The only way you can do this in Matz's Ruby currently is with a gem called parse tree that Ryan Davis wrote, which actually jumps into the C, pulls out the S expression, and then returns it as an array, just like this, actually. The neat thing about this is that once you have the code representation of the code, you can do really weird stuff with it, like write refactoring browsers or code mutators or interesting introspection tools. You could write a Ruby lint with this sort of information, and all of it's available right there. Since I'm still in the code, let's do the foreign function interface. So this may be my hands down favorite feature because I have to jump into C land all the time. I do lots of C extensions and optimizations and systems work. And see that string. And I was one of the people actually to work on dir.rb, which was really cool. The problem with these methods is if you don't already have primitives to say, let's work with the file system, let's make a directory, you can't really write that from Ruby without starting to write some C. But Rubinius has something called a foreign function interface, which lets you attach C methods to Ruby on the fly without writing any C. So you'll notice here with makedir, we're calling into this POSIX namespace and class called makedir. That is defined right. Well, that's the file system. Here's directory. Here we go. Makedir. So with the foreign function interface, we attach the function makedir, which takes a string and a short and returns an int. That attaches to the C method in the standard library, does the type translation, and calls it. No C extension. No MKMF, no dealing with compilers, no dealing with gems installing or compiling on install or prepackaging. One line. That's awesome. So working in the internals, that's been one of the true delights. While I'm on neat C extension, non-C extension stuff, C extensions will and largely do work with Rubinius. We've got a interface called subtend, which provides the ruby.h that all C extensions compile against, and generally provides a transparent interface so that you can just compile C extensions like Mongrel against Rubinius out of the box without changes. I got Mongrel working for the first time. In fact, I think on my desktop is Hello Mongrel. This was the first Mongrel handler running on Rubinius a few months ago. So we're going to have compatibility with all those gems that the JRuby guys have to rewrite in Java or deal with JNI. And for the last cool Rubinius trick, let's look at the call stack, because this is just the prettiest thing I've ever seen. Sometimes the call stack in Matz's Ruby just gets really gross, and you get the ... so many other calls, and you're not really sure what's yours and what's in the standard library. This is what a call stack looks like in Rubinius. You'll see the red one is where the actual error occurred. These are calls in my program, and the blue is all stuff that happens in the Rubinius VM itself. And it's just really clean and nice to work with. And if you're going to get errors, I think this is the right way to do it. So that's, let's see, I think that's what I was going to talk about with Rubinius. Questions, concerns, interests. For some things it's faster, for some things it's not. In general, it's not as fast yet. We've mostly been working on completeness. And completeness is really, really coming around, which is pretty cool. I think they got MERB working for the first time last week. How hard is the portability going to be? Portability in what sense? Mm-hmm. Yes, and Rubinius builds with GCC. The core stuff does. And then it compiles all of its Ruby files itself using pre-compiled bundles that came from the last version of Rubinius, which is sort of weird and kind of cool.
So it's fully encapsulated?
Yes, it's fully encapsulated. In fact, if you download it, all you got to do is rake build, and then everything's happy. That's what I did this morning for the new tree. I had something related to that. Contribution. Rubinius has something called what are we calling it? An open commit bit, or promiscuous commit bit, or slutty commit bit, or something like that. If you get a patch in, you get commit bit. Period. It uses Git these days, which means it's easier to revert your changes if you horribly destroy everything. But it's not likely. We sort of feel like if you're making the effort to get there and to get a patch in, and it's something that we reviewed and is acceptable, we'll trust you until we can't. Yes, that's a great question. So for the podcasters, the question was, do we have a nice detailed set of tests? And the Rubinius tests are actually used with JRuby now, and I think IronRuby, and we're all sort of collaborating on probably the closest thing to an executable Ruby spec as is out there. There's a ridiculous number of specs for a large set of for a large subset of the language. Even really weird stuff that's hard to test. In general, is well tested or going in that direction. Other questions about Rubinius? Matt? Sure, I can't talk about Gemstone, but JRuby is really cool. It allows you to hook into Java libraries natively, just like you can, well, not in the same method, but like you can attach C functions in Rubinius, you can load and interact with Java libraries in JRuby. They're doing some really cool stuff. I think they got a bytecode compiler working a little while ago. And things are being run on production on JRuby, and it's really exciting to see an alternate implementation starting to gain ground. I think it's good for the ecosystem to have multiple implementations for different use cases. As far as I remember, and I know I'm going to get this wrong and somebody's going to call me out on it, but IronRuby isn't, I don't believe it's as complete as some of the other implementations. If I recall, it started as a research project at Microsoft. Somebody stop me if I'm wrong. And I haven't seen many reports from them except the talk at RubyConf. last year. Let's see, which other VMs were? I can't speak to Gemstone. I just saw the emailed list last week with the interview. So, yeah. Oh, yes. And then there's Yarv, which that's Ruby 1.9 is Yarv, right? Yeah, and it seems to run. Yes. So all I can say to that is there's been a Yarv status report at every RubyConf I've been to. So good or bad, they're the official. So I think Rubinius is different and interesting, and when it's fully up to snuff, I'm gonna write my holy grail refactoring browser in Ruby, and it's gonna be awesome. Because that's what I've been waiting for a long time. Accessibility to Ruby programmers. My first contribution took half an hour jumping into some library somewhere. You know what? Let me. I actually had this up to show off. So this is dir.rb, and it jumps into CLAN, so it's sort of a bad example. So let's look at string. This is how squeeze is implemented in Rubinius. It's these 25, 30 Ruby lines. It's really Ruby in Ruby. If you understand Ruby and there's fundamental stuff missing or things that aren't supported, you can jump in and you can write it. You don't need a background in C. You don't need a background in Java. You don't need to understand the VM architecture. You just need to understand what you're trying to implement or have a failing spec. A lot of people jump in by writing specs. This isn't working. This is how I isolate the case. That's a patch. That's enough of a contribution to continue. No, for the end user, you don't really care about that. And what I think is going to be interesting for the end user with Rubinius is the new stuff they're doing, like multiple VMs within the same running environment and message passing there, and the stuff you can do with S expressions, and the fact that C extensions can't crash Ruby anymore because it runs in a fully separate stack. You can rescue from a seg fault in a C extension, which is how cool is that? That's the reasons I'm going to use Rubinius, because it's the Ruby I can hack on, and it's the Ruby that I feel like there's lots of advantages to not being the official version. There's lots of things we can do because that's not what we are, and I think that gives it a bright and exciting future. Other questions on Rubinius? Okay, well, let's go to the next thing. Let's do the address parser, because it's the next most complete, and I'm sort of dreading hitting the next two topics. So how many people have played with or seen Treetop? Okay, so Treetop is something called a packrat parser. I can't really explain to you what that means. I tried to read the Wikipedia article and it just wasn't parsing. So I'm going to leave that to Nathan, the creator, because he's really good at explaining it and I'm really bad. What I want to do is show you what you can do with it, because it makes writing grammars for things that are a little too complicated for regexes, but you really don't want to write an LALR parser, and you don't want to go into Yak, and you don't want to screw around with that stuff. This is the middle ground. This is great for a lot of things. And what I want to show you is a U.S. postal address parser that I wrote. My friend Nitai Jaffe and I wrote a few months ago in an evening using some tests. In fact, I'll show you the test and the parser. So just so you can get a scope of it, the only thing that's folded in these code samples is special helpers for accessing the things I'm pulling out. But by and large, this is the grammar for parsing a postal address. This is it. And you'll see a lot of this is literals, where we said, okay, we're just going to enumerate all of the possible suffixes. This is where we're going to enumerate all of the possible states to make it easier to work with. So let me show you what's going on here. No errors found. That's good. I'm hitting the wrong button. There we go. Okay. So this is sort of a pseudo Ruby file. What you're doing is writing treetop patterns. And within the treetop patterns, let me unfold some of this. I guess I'm going to have to back this up. Within the treetop patterns, these take blocks, which let you define things that can be accessed once that pattern has matched. So the top level pattern goes at the top. So we're going to define this rule called address. This is what an address is. And the address pattern has a number, and then a space, and then a street, and then possibly, so just like in regex, this is the question mark is may or may not exist once. A separator and then a detail. So I think detail in this case is sweet, or those sorts of things. But we can check below in a second. Then a separator and a city, and a separator and a state, and a separator and a zip code. And that is the top level structure. Within here, what we've done is define these helper methods. So when we actually parse this address, we're going to get an object back. And on the object, we want to be able to access certain attributes of it. So in this case, we've added a number accessor, which super... Why did I use super there? Oh, so the reason I use super here is because if I didn't define this helper, this value would actually be what is returned if I did dot number. So in this case, I ask for that and then ask for the text value and then coerce it to an integer. In this case, we have a name on this object. Yep, Patrick. Okay, sorry. Now that we don't need to see the whole thing. So in name, if I'm asking for a name on a parsed address, what I want is the street name of the street. So what this gets into is sort of the definitions further down. So if we look at a street is a street name, space a suffix, or just a street name. So up here, when this is parsed, I have street because of this, and street relates to the rule street, which has these things. So we're basically defining attributes on other objects based on these pattern rules. And based on these, you can make really powerful stuff. If you look at this, most of these patterns are fairly straightforward. The only really complicated thing in this parser is either string with optional period, or I think there's a separator option down here that was confusing. Oh, here we go. Cannot be followed by not a space or comma. Sometimes you get these weird edge cases in matches where you sort of have to say, it's not what I'm looking for, it's what I'm not looking for. Which is strange. But based on, let me show you the tests. Based on this series of tests, which all it does, so we've got the should parses address. All this does is run the parser on the string, and then split these out and say, okay, well, from the parse, the number should be whatever the number I passed in was, or the name should be whatever the name I passed in was. So based on building up these very basic specs, so originally just 1187 Valencia was just an address is a number and then a set of characters. And slowly building up, adding these simple rules in Ruby, you can do really powerful things. So down at the end, we're doing things like, so there's ambiguous parses further down here, but 2029 Hearst Ave, Berkeley with no punctuation properly splits out because it knows that the city comes after the suffix. So, with relatively small amounts of code, you can do really powerful things that would be really, really difficult to do with a regular expression. It's a lot more expressive. It's a lot easier to understand, even the complicated parts. And, it's all in Ruby, so you don't have to deal with one of the other tools. I think that's probably it. We're actually going to be releasing this at some point because I think it's a generally useful grammar. Other neat things about Treetop, it's composable. So if you have multiple grammars, like something that handles arithmetic and something that handles... actually, I have examples down here. Nathan wrote a Lambda calculus grammar that is able to be run using its eval helpers that have been added by composing some of its operations. And let's see. So here's the Lambda calculus grammar, which explains how an expression is built up. And all he did was include the arithmetic grammar, which had been written separately, and now the two can be used together. You can easily say that certain results need to come back as a different type of class. So you notice some of my helpers coerce things to integers. Well, if what I really wanted was for them to be coerced into a different type or a different class, that can happen too. It's, as far as I can tell, it's got most of the capabilities of Yak or another general parser. I think you could probably write a Ruby parser in this if you had an infinite amount of time. I think it's generally useful. We should probably create something somewhere where you can toss up grammars and then work with them together. LazyWeb should get on that, or I'll find a weekend. So that's Treetop. Questions, Rob? I think it does, actually. Do you want to throw stuff at it? I can pull it up. I think that's what I actually set this up for. So I just make this address parser.new. The address is parse. So the only restriction you're going to see on this is we said it's just easier to work with if everything's lowercase. So I'm only going to write it in lowercase, but otherwise it should generally work. Oh, this will not parse. Submit it. I'll add it to a test case. We'll figure it out. If anyone else want to throw weird stuff at it? Because our friend Coda was... You get really weird stuff at the end here where... Oh no, it's in our other set of tests. Just like you should see some of these. So what we were doing was writing a system where you could send via Twitter an address that you were parking at, and it would remind you when street sweeping was coming by, so you could move your car. So we wanted to be able to handle, any address we wanted to be able to park at. So let's see, there's ambiguous parses down here somewhere that we actually handle correctly, remarkably. So this was where we started handling suite numbers and apartment numbers and really bizarre stuff. And there's actually, maybe I just don't have the most up-to-date code, but there's things that look like they should be suffixes, but they're actually cities, or cities, but they're actually suffixes, and it gets really complicated. And it was really a lot of fun to write, actually. And the parser is still only about 180 lines, which was nice. It doesn't do foreign addresses yet, but if I throw it up on GitHub, you could fork it, and then somebody else could do it for me. And that would be great. Yes. Sure. 11092. Northwest. Oh. And that should be northwest. Passage. Street. Oh. Sorry, that's actually name. Street grabs the object. A is name. There's no suffix. Is passage supposed to be a suffix?
No, in fact, Google Maps writes something, but you gotta...
Nice.
It's actually my address now.
Cool.
And you can't set the default for it. You cannot set the default for Google Maps for it to live in there. You can go for it. You can search for it online.
Really?
If you set it as a default, then you can go to Google Maps and it says, I can't find it. And the change to Northwest, they never happened.
Oh, okay. Right. Yeah, these can get really confusing. I think we actually had something like that. It's Tree Lane Avenue. Oh, you know what? Oh, so A dot number. It probably got it as the city. Yeah. Actually, so here's the cool thing. Our parser parses it this way, but when we actually look up street segments, if we can't find it, we grab the city and attach it, and we start splitting off the tokens and saying, well, could this actually be that? So for certain cases, it takes a little bit longer, but we usually get it right. Patrick. Okay. East Lane Street. So if that's the name, see, this is why I give it to other people to break. It's pretty good for a lot of things. Oh yeah, totally ridiculous. Yeah, we're just going to continue breaking my software until I feel that. 10. I wonder if that parses. Number. Street. Oh. City comes out halfway. Yeah, you get. Yeah, it gets really bizarre, which is why other people should contribute back to the grammar when I put it online, because there's like an infinite number of these. Or the USPS should just provide a web service. Yeah, no, you need. Yeah. Go ahead. Mm-hmm. Sure. That you need to pass. Okay, yes. So there's a way you can actually bind things to be passed in. And he does this in the Lambda calculus parser. So let me look for this. So if I can't find this in the next 10 seconds, I'm just gonna skip it. But I will tell you, I have seen it done in a live coding session at RubyConf. He wrote an arithmetic parser on the fly as part of his talk, which was really cool. and you can bind variables that get passed in. So yeah, you can write all sorts of neat DSLs using this in fairly little amount of work. I think he actually printed out packets for us at RubyConf, and I think it was the Lambda calculus parser, including the arithmetic stuff in Treetop, which would run, was 2 or 3 pages. Might have been 2 pages. Okay, so are we good on Treetop? Other questions? No. Okay. So these last two are going to be a little bit lackluster, because one of them I would need. Well, Curie's not so lackluster. Let's do the lackluster one first, and less sad. So who knows what kqueue is? We've got one. Oh, we've got 3. Cool. Okay, so kqueue is an event subsystem on FreeBSD and OS X, and what it's used for, well, okay, who knows about netlink or iNotify or, okay, good. Okay, so it's an event subsystem in the kernel that lets you ask to be notified when certain things happen. So with kqueue, that's you can ask for process creation or destruction or other things happening. You can ask for when files are modified, or if there's information available on a socket, or it's ready to write. A lot of the things you might use a select for, or some other way to watch a file descriptor or input device. It provides a more scalable way where you say, I just want to look at this one, and I just want you to tell me when it happens. I don't want to keep asking. So one example of a place that this has been used is if any of you have used God, the monitoring system. There's 2 C extensions that I wrote in there, one for kqueue, one for netlink, that lets you say, I want to watch when this process goes down, tell me. And what I wanted to do was write a more general version of this where you can interact with all of the interesting things that kqueue has to offer, because it does a lot more than process monitoring. It also does file system monitoring and some other things. If you have a Mac or a BSD machine, man kqueue will bring up the man page, and it's got lots of information. Anyway, so what I wanted to write this for was I've got a little Apple Mini sitting in my living room that's my media center, and we've got other machines in the house. And I wanted to say, okay, well, when I rip music to my laptop and I want it to go on the media center, what I really just want to do is transfer the files and have it get added to iTunes, or have it put in the right place. So I said, okay, well, I have SSH access. Let's just SCP it over to the right directory. I'll write a little script to do it, and we'll have a little process sitting on there that watches that and uses, if any of you have seen RBOSA, or if any of you haven't seen RBOSA and you're on OS X, you should really take a look. It lets you hook into all sorts of applications really easily. Anyway, have it watch this directory and then add it to iTunes when it shows up. And so from that was sort of half-born Ruby kqueue. And the reason I say half-born is it's basically working, but not really something I would tell anyone else to put into production ever yet. Right now, all it does is monitor files, vnodes in the kqueue parlance, and it doesn't do it very well yet. It does get notifications back when things happen, but it gets them back multiple times, and I'm not sure why. I was working on fixing this on the plane. Anyway, so what I'd like you to be able to do when this is all ready to go, this test actually does pass. It just passes multiple times. So if you include this Ruby kqueue and create a new thread that handles the events, this actually calls into the C and does a loop and says, okay, when the event is ready, call back into Ruby and execute the proc that I've passed to register. So in this case, we're registering an event on temp, which is going to be a vnode event, and it's going to look for writes. So if we write to that file descriptor for any reason, then this proc gets evaluated, and the global variable RET is set to 42. And then I open a file inside of that directory, and it says, oh, you've written to the directory, and then it's equal to 42. And that actually works. But it's not done yet. But when it is done, you'll be able to make all sorts of interesting things by monitoring the file system or the network or processes or, I think my end goal is probably going to be something like a lib event for Ruby that handles netlink and kqueue and whatever Sun's doing and various other stuff. I kind of want to write a unified interface. This is on GitHub under my account, Kevin Clark. If you want to contribute to it, please do. I don't have lots of time these days. Maybe more soon. But in the meantime, this has sort of been passed off for work stuff. And it uses Ruby inline. So if you're interested in that, it's on there. I was sort of playing with it as a way to get away from normal C extension stuff, or just try it out. Are there questions? Okay. Well, let's just do a quick rundown for a system we're calling kqueue. This is something I wrote for work. How many people know what a continuous integration system is? How many people have worked with BuildBot? Oh, well done. BuildBot is a continuous integration system written in Python. And then one of the nice things about it is that the architecture is a sort of master-slave architecture, so you can have lots of builders on lots of different architectures, and that's something we need at work because we're building on 3 different ones, Linux 32, Linux 64, and OS X. And it's great until you need it to do something it doesn't already do. And if you look at the code, it looks like it started as this really slim, sexy continuous integration tool, and as they kept adding features, it just got harder to maintain. It's bit rot. It happens. And I spent about a month trying to modify it to do something we were calling ad hoc build. So what we wanted to do was take a package. So in our packaging system, there's dependencies. Everything will install properly, generally. We wanted to say, take package of version X and package of version Y that's somewhere down the dependency tree, do the dependency solution to figure out what's in the middle, and build something that links against those things, and see if it works. The depth solver isn't so bad. The graph stuff isn't so bad. Getting BuildBot to define builds that weren't defined when it started up is near impossible. So what I did one night was get frustrated and start writing another system. The reason I rejected things like cruise control and such is they're sort of focused on certain types of projects and a certain infrastructure where you're running it on one machine. We really needed multiple machines, multiple architectures, and we wanted to be able to get stuff through quickly. So what this turned into is sort of a continuous integration or build framework. It's glue that lets you take a master and a slave and sort of give it arbitrary commands that do things and fetch files and then interact with how that data worked in some way. So first, I'm just going to show you what the front end looks like at the moment. I don't have net access, so this I can't show you a lot. So these are all of the projects we're building right now. We've got a ridiculous amount of software building all the time that interacts on everything, on 3 different architectures. So what we've done is built this so that you can easily add builders to categories. So we say we have 2 machines that are Darwin machines. We have 2 machines that are 64-bit Linux machines. And kqueue is able to say, I need a machine that does this, and map to the next available builder. And so we're able to load balance across as many machines as we like. And I realize this is sort of turning into a product talk, and I don't want that to happen, so we're going to jump into code in just a moment. But if you have a need for configurable, large-scale, scalable build systems, please come talk to me, because we're going to open source this as soon as launch happens. I've got some guys at Songbird. I don't know how many of you know Songbird, who have to build Mozilla plugins on a dozen architectures, and so they're going to be joining in on this as well. If you have to build lots of stuff, or you have to build lots of stuff on lots of different machines, this is really useful. So let me show you some code. This is the base trigger. So if you want something to happen after some other event in the system, a build is finished, a step is finished, a set of builds is finished relating to a project, this is how you access it. And this is the entire base class. All we do is have a class. Let me bump this up. All we have is a class that takes a method notify with a type, the event, and an arbitrary details hash. And then if this object responds to a method called the type underscore the event, then we send that. So what this turns into is, let's do the email notifier first. Is things like the email notifier, where we say when the build set has ended, that's a set of builds relating to a project on however many machines we built it on. Then we're going to go to the database, we're going to look up people who have asked to be notified for this build, and we're going to build this tmail object and send it off. We even do things like implement part of the notification system in the notification system. So the build set finish trigger, you can't actually know if a build set has finished unless you know all of the builds have finished. So the build set finish trigger is implemented by saying, I'm going to get a notification every time a build ends, and I'm going to see if all of it's completed. And if it's completed, I'm going to fire off this new event by calling notify again. So the whole point of the system was to have something that could easily be modified for any sort of large scale or even small scale build usage. Everything goes through this. This is how we build all of our software. I had a lot of fun working on it. Another guy internally, Kevin Lingerfelt, who hasn't pushed any open source software yet, but will be the maintainer for this, has done a really amazing job polishing this up. I'm really excited about this software, and the next place I go, whenever that is, wherever that is, we'll be using this for builds. Because you can do stuff like, say, I want you to run these arbitrary build steps taking, this source from this place and run it on these many machines, and it'll just do it, which is pretty cool. Let's see. So as I was saying, it's really, really pluggable. You can plug in any sort of source control you'd like, as long as I think the methods it needs to respond to are fetch head and fetch changes, and it'll pull back a list and then be able to spin off whatever system you'd like. It should be fairly trivial to build a class to go with your pet source control module. The load balancer is 37 lines. And this it's not modifiable right now, but we could put an argument in to initialize so that you could put in your own sort of queue system. This one is database backed, but earlier it was in memory. You could do flat files, you can do it however you'd like. It also needs to be able to increase and decrease priorities. If you want to support that, you could just comment it out if you'd like. So I think this can be useful to the people who need this sort of thing, and it's fun to hack on. So, are there questions? Yeah, it's sort of a subset of what some people need. Anyway, if you know somebody who could use this, tell me, because I'm always looking for contributors. I'm sorry? Sony? Sure. I should send an email to the list. I know some people who have this sort of issue, and it's really satisfying being able to install a gem on a new system, and double your capacity for how many builds you can do.
That concludes this episode of the SD.RB podcast. See you next time.